In section 4, we're going to focus on dependent probability. So we did discuss dependent probability a little bit when we were talking about independent, but we're going to focus on it completely here. So two events are dependent if the probability of the next event is affected by the previous event. So remember, independent and dependent work for if you're doing multiple things. If you're only doing one thing, like you're only picking one thing out of a bag, or you only find the probability of one thing happening, you don't have to worry about independent or dependent. If you're going to do multiple things, like drawing two things or doing two events, then you have to worry about independent and dependent. So for our first example, we have there's a bag of 20 marbles containing 4 blue, 9 orange, 1 red, and 6 green marbles. You draw 2 marbles out of the bag. Are the events drawing an orange and red marble dependent? Why or why not? And they are dependent. So remember when we were talking about independent and dependent the first time, when we were drawing things out of a bag or drawing cards, we had to look for the with or without replacement. And I told you I would specifically mention if something was being replaced. And here I don't mention that the marbles are being replaced. So they're dependent because you are not replacing the marbles. For our second example, you play a game where you draw a card from a deck, look at it, and then replace and choose a second card, look at it, then replace it. Are the events of drawing the cards dependent? Why or why not? So in this case, we have independent events. And the key things are that you are replacing the cards. So remember when we talked about independent versus dependent, anytime where you're drawing something out of a bag, drawing a card, anything where you're picking something out, that's when you have to worry about it being independent or dependent. Flipping a coin, rolling a die, spinning a spinner, those are things that we said that are going to be independent for us and we don't have to worry about them being dependent. So let's talk about the formula. So A is going to be our first event, B is going to be our second event. You have the probability of A is the probability of event A, and then the probability of B is event B. And then for our formula, the probability of A and B is the probability of A, because the first event does not change, because that's the first thing you're doing, times the probability of B given A. So that vertical line there represents given. So it's finding the probability of B given that event A has already happened. There is a specific formula for it, but we're going to do a very basic version of given, so you don't have to worry about it being too complicated. So for an example, we're looking at our marble. A is drawing our orange marble, B is drawing our red marble. We want to find the probability of A and B. So for the probability of A and B, probability of A, so it doesn't change, drawing an orange marble, 9 out of 20, times, and instead of just doing the probability of B, like if they were independent events, we are going to treat it as, all right, what's the probability of B given A has already happened? So we know that there are no longer 20 marbles in my bag. There are only 19. And now my numerator is just going to be the number of red marbles, which is 1. So remember, you multiply straight across. So 9 times 1 is 9, and 20 times 19 is 380, which does not simplify. And 9 over 380 is about 0.024. So just a little over 2% chance that you draw an orange marble and then a red marble. For our last example, we're going to look at the probability of drawing an ace, a 2, and a 10 from a deck of cards. So here we have 3 events. So we're finding the probability of A and B and C. So I'm going to let A be an ace, B be a 2, and C be a 10. So you can keep adding like the given probability. So the probability of A is the probability you draw an ace, which there are 4 aces in a deck of cards, so 4 out of 52, times. Now, because I've already drawn a card, there's now only 51 cards in my deck. There are 4 2s, so 4 out of 51. And now there's only 50 cards left, and there are 4 10s. So you can just keep multiplying your probabilities together. So 4 times 4 times 4 is going to be 64 over 52 times 51 times 50, which is 132,600, which is going to simplify. They are both divisible by 8. So we're going to get 8 over 16,575, which is the smallest it goes, which is, if you're going to do a decimal, about 0.00048. So very, very, very unlikely that you draw an ace, a 2, and a 10 in that order from a deck of cards. Let me know if you have any questions about dependent probability.